All right, guys, I'm going to give you a little help for Hooke's Law Lab number 2. Here again, it'll look like this. The document will be this top thing, and then this will be the link to go to PhET. So when you click on this top thing here, the lab should pop up. There it is. I stole this one. Been doing this one a long time. I like this one, so it's good. So this one kind of starts, and they kind of assume that you haven't studied Hooke's Law or any of these things, and so they try to kind of walk you through it, but we should already know how to do these things. So these are questions you have to answer. So it says, write the equation for Hooke's Law. Okay. There it is. Make myself big. There's the equation for Hooke's Law, right? Okay, there you go. So you can write that. Now, it says explain what it means in words. Very few people do this and do this right. Okay, so what does the equation say? What's the equation got in it? I really want you to tell me what the little minus sign means. If you watch one of my videos, you'll be able to tell me what the little minus sign means. All right, and then you got to answer some questions. And then right here it says, if you had to write a formula for the period of the spring, here and here, what would it be? Make myself big. Period of the spring, there it is. 2 pi square root of m over k. M is mass, k is the spring constant. There you go. That's what you're going to write. Okay. Now, then you have to start doing some stuff. And the lab that I made here, I fiddled with it. It has these little data tables that you're going to fill out. So the first thing you're going to do is find the spring constant of spring 1. Okay, so let me go back here. I'm going to click on this link right here to take me to masses and springs. I'm going to open this up. Here again, they've updated this so it looks a little different. I can just do the intro one, right? Okay. Spring 1, here's spring 1. Okay. And let's see what the lab says. We're going to use Hooke's Law. All right, which means we're using f over x. So this is very similar to what you did in the first lab. You have some masses, and you're going to find the change in stretch. Oh my gosh. Right? So you can take start with your 50 gram mass, hang it on there. You want to hit this button to get the dang thing to stop. You can click on these 2 lines. You're going to measure the difference between those 2 little lines, the blue line and the green line. That'll be your change in stretch that goes in here. You're going to have to convert from centimeters to meters. This is in centimeters. You got to convert from centimeters to meters. Put that in there. And then you're going to calculate K's using Hooke's Law. Hint, these 3 numbers should be the same. Should be the same thing. Dang it. Should be the same thing for this spring. As long as you don't fiddle with this button, your K's should be the same because all springs have the same K. Right? So this spring should have the same K no matter what you hang on here. Stop it. Right? So that's what you're doing. Now down here, you're going to do something different. You're going to try to find K again. These K's and these K's should be the same or really close. Okay? And you can ask me, Sharkey, does this look good? Send me a note. I'll tell you because I know what the K is supposed to be. You have the same masses, but now you're going to do oscillations. What the heck is this? Well, we're doing the same thing. We're going to find K, but this time instead of using Hooke's Law, we're going to use this. Make myself bigger. We're now going to be using this equation. We're going to solve for K. So this takes a little bit of mathematics. We need to solve for K. I'm going to divide both sides by 2 pi. I'm then going to square both sides to get rid of the square root. I'm then going to solve for k. I'm going to multiply both sides by k. And then I'm going to move all this crap to the other side. So k will be equal to 4 pi squared m over t squared. That's your equation to solve for k for this part of the lab. 4 times pi squared times mass in kilograms divided by t squared. T is the time in seconds squared. There's your equation for this second part of the lab. Make myself small. So for this part down here, that's what you're going to be doing. You're going to time oscillations. You're going to find the period. Okay? The heck is this? What are we going to be doing, Sharkey? Okay. So you're going to keep the spring the same. You don't need the ruler anymore. What you're going to do is you can hang a mass and it will oscillate. Right? Move myself over here. I can go to slow. I can slow things down, right? So it's going to slow down. So here's what I'm going to do. I'm going to wait till it gets all the way down at the bottom here and stops, and I'm going to hit pause. This is why I like doing labs on the computer, because we can pause, we can cheat, basically. This is essentially what we're doing. We get my timer out. I'll press the timer, start, but remember, I have it on pause. And now I'm going to press play, and my timer should start. There it goes. Spring's going to go up. It's going to come back down. When it gets down to the bottom, all the way down there, and stop. I'm going to press pause. And my timer stops. There it is. That's my time it took for one full cycle to go up and come back down. Okay? So you don't have to actually, in the lab it says you're trying to find the time for 10 oscillations. You don't have to actually do this. You can find your period just by doing what I just showed you, using these little buttons. So the period here is about 1.32 seconds, which means in my equation down here, my t in the bottom of this fraction is going to be 1.32 squared. That's my time. If you're doing this, right. And then you're going to find k. Most of the stuff at the top, the only thing you're going to measure is t. And these k's should be the same as these k's. And if they're not, something's wrong. And we got to figure out what it is. Move myself back over here. Okay? So that's the front of this lab. On the back, you're going to then find the average of all these k's and use an average value here to do all this other stuff. So what you're going to do on the back is, using the average k for this spring, you're now going to have to figure out, what are these masses? What are these masses? And I'll let you figure out these masses in any way you want. I think the lab says you're supposed to figure out these masses using both Hooke's law and SH. You can just use Hooke's law. That's fine with me. Now look, this can't be that hard. Look at this yellow mass. It's about the same size as the 250. It's not quite as big. So it's going to be a little less than 250. Look at this turquoise mass. It's a little bit bigger than 100. It'll be like 150. Look at this little pink mass. It's a little bit bigger than 50. It's like 75. I mean, there you go. Okay? So you're going to have to try to find those masses. Now, how the heck are you going to do that? Well, you know what the K is for your spring. So in the lab here, see if I can get everything to drop. And right. There we go. All right, so how am I going to do this part? How am I going to find all of these unknowns? I know what the K is now because I did all this work on the front, right? So I know the K of this spring, which means if I hang this, can I measure the stretch here from the blue line to the green line? Right? So if I use Hooke's law, that's X, because I'll figure out what my stretch is. That's X. K is what I found on the front. K doesn't change. For every individual spring, K is a thing for that spring. It doesn't matter where you take the spring, K will be the same for that spring. As long as you don't mess with this little button right here, this little button changes what K is. So anyway, you can measure stretch of the unknown mass, right? You know what K is. You can solve for force. Force is equal to mg, and then you can solve for mass. You got to make sure that G is on Earth, right? So that's kind of how this lab works. And then they're going to have you solve for some other unknowns. Here, for number 9, you're going to figure out what is G on the moon. Okay, well, in order to do that, you can take a known mass and hang it from a spring. You could actually do this. You could actually go to the moon, take a spring of a K that you know. So here again, we're going to know what K is because we already found it on the front. You know what the mass of this is. Mass doesn't change when you take masses to different places. And then I'd have to hit this button and change it to moon. You can solve for G on the moon. I like this lab. It might take a little while, but it's got some good questions here at the end, and there's a lot of good things here. So give it a go. Ask me questions as you go, and I'll hopefully be able to help you out. All right, have fun.